The mounting distance of a bevel gear is perhaps the most important parameter for proper operation. Mounting distance can best be defined as the distance from a locating surface on the back of one gear to the center line of a mating gear. The optimum value for the mounting distance is established by running the gear set and adjusting its position to obtain a tooth contact pattern that is consistent with smooth running and optimum load distribution between the mating gear teeth. Because of dimensional variations between parts, each gear in a set has a unique value for the mounting distance, and in most cases, this value is permanently marked on each gear. Here we see a graphic representation of the gearbox. The mounting distance for the gear member is the distance between here and here. The mounting distance for the pinion member is between here and here. To run properly, these distances must be correct. In some cases, the mounting distance isn't easily measured in the gearbox, or the customer needs to change the backlash. This will require verification of the actual contact pattern to ensure the mounting distance is correct. Checking the contact pattern is addressed in an upcoming section. During manufacturing, once the optimum tooth contact is obtained running the parts together, the mating teeth in engagement are marked for identification. Often this is the tightest point of mesh where the normal backlash should be measured. These are considered to be the matched teeth. These marks usually consist of X's or dots on two adjacent teeth on one gear and the mating tooth of the other gear. When assembling the gear set, it is essential to position the single marked tooth in the space between the two adjacent marked teeth. Another critical parameter for a bevel gear set to perform properly is backlash. Backlash in bevel gears is defined as outer normal backlash or transverse backlash at the tightest point of mesh. Backlash can be larger at other points of the mesh, but not smaller. Unless otherwise specified, normal backlash is measured normal or perpendicular to the tooth surface. In other words, backlash should not be measured in the plane of rotation. In most cases, the manufacturer marks the normal backlash value on the gear. For the purpose of illustration, we'll show how the backlash is checked in a tester. However, checking backlash in a gearbox is theoretically performed in the same way. The mounting distance of the gears is first set and the mating teeth are aligned. Then an indicator is placed on the gear tooth surface. Again, the indicator must be located normal to the tooth surface, as is shown here. First, the pinion member is locked, so it will not rotate. Then, the gear member is rocked lightly back and forth. The maximum value on the indicator is considered to be the backlash reading. It's important to keep in mind that the orientation of the tooth to the indicator is essential for obtaining an accurate backlash reading. Here we see the proper orientation. For critical applications where backlash is small, it's a good idea to check the backlash in several areas. Runout from the gearbox's bearings and shafts can change the location of the tightest point of mesh from the matched teeth to another location. An important note here: sometimes it is not possible to locate the indicator normal to the surface, and the backlash measurement must be made in the plane of rotation. Measuring backlash in the plane of rotation will provide a reading that is called transverse backlash. However, this value can be as much as 40% larger than normal backlash. Please contact AeroGear's Design Engineering Department if you need to use this method. When mounting distances have been marked on one or both gears, position the gears with these distances first. Then use the normal backlash value to verify proper assembly. It's important to note, before checking the backlash, at least one of the gears, preferably the pinion, must be installed and positioned at its marked mounting distance. However, it is best to do both members whenever possible. The reason is this: because bevel gears are conical in shape, they can be assembled in an almost infinite number of positions, most of which cause poor performance, while still having the desired backlash value. On gear ratios greater than 1, the pinion position controls the contact pattern more than the gear. The gear controls the backlash more than the pinion. As the ratio increases, the effect becomes more dramatic. 1-to-1 ratio gears control pattern and backlash equally. Frequently, an assembly technician will assemble the bevel gears and obtain the desired amount of backlash without regard to the mounting distance. In this example, we see a set of gears that are dramatically out of position from their proper mounting distance. It's actually possible to obtain a proper backlash reading in this position, but overlooking the mounting distance can have a very negative result. This is sometimes done with low-quality or lightly loaded bevel gears. Although overlooking mounting distance will occasionally work, it is a risky approach when the gears will be loaded to their maximum capacity. This will most often result in shorter life and poor performance. So it's important to remember to start with the proper mounting distance, then obtain the designated amount of backlash.